Hello everyone. Welcome to switispeaks official YouTube channel. I am Sweetie Panjani. This is systemverilog assertion series. Today we will learn about immediate assertions. Let's see what is immediate assertion. First thing to note about immediate assertions is it's non-temporal. What do I mean by non-temporal? Non-temporal means it has no relation to time. It is not dependent on time. It executes immediately. That's why it's called immediate assertion. It does not wait for anything. Another important thing about immediate assertion is it should always be used inside a procedural block only. What are the procedural blocks in system Verilog? It is either initial block or always block. Your immediate assertions can be only inside initial or always block. It cannot be used in continuous assignment. Please take a note of it. Only inside procedural blocks. It can only have combinational logic. You cannot use sequential logic because it's non-temporal. You cannot include any timing relation with the immediate assertion. That's why only combinational logic is allowed. These things are very important to remember for immediate assertions. Next thing is, let's see what is the pass or fail action for the immediate assertion. Pass or fail action means what happens when the assertion passes, what happens when the assertion fails. How are these implemented? First thing to note, in case of immediate assertion, you can have multiple pass and fail actions. Mostly we don't use multiple, but it is still supported. Another thing to note for the immediate assertion, it executes immediately after the assertion evaluation. As soon as the assertion is evaluated, it executes. Let's see an example now. Uh, Now see, we have seen that there are different types of assertion statement. There is assert, assume, cover. You can use immediate assertion in any of these. We'll see multiple examples. Say for example, I want to check that enable signal is always 1. Then I can use now this assert enable. This is called as label. Whenever I call assert enable this label, it means I am referring to this code. Then you are using the keyword. It can be assert, assume, cover. Here I am using assert. I am saying assert enable. It means check enable is always 1. This is the pass section. What should happen when the assertion passes? I am displaying enable asserted. What should happen when the assertion fails? I am displaying enable not asserted. I am printing an error. Then we can also use assume. Here I am assuming that A and B are both 1. And then the pass action is display A and B is true. Fail action is error. A and B is false. This is the label. Assume A and B. I can also have cover. Here the label is cover A and B. This is the statement cover A and B, and here I have only pass action. These are the examples. Now let's do one thing. Let's run a code. We will run a code, simulate it, and understand the output. Let's do that now. This is the coding example of immediate assertion. I'm using 2 is to 1 mux. The functionality of 2 is to 1 mux is it will have two inputs. The names are I0 and I1 and one select line. Depending on the select line, the values of either I0 or I1 will go to the output Y. Say for example, select line is 0, then I0 should go to Y. If select line is 1, then I1 should go to Y. This is my functionality. Now I am writing assertions to check this behavior. If you see, I am having a case statement where select, depending on the select, my case statement changes. If the select is 0, I am creating a label for my assertion y equals I0. This is the label. I'm using assert statement, assert y equals I0. This is checking whether y equals to I0. If it is equal, this is the pass action. I'm displaying y equals I0 for select 0, else this is the fail action. I'm displaying y not equals I0 for select 0. Similarly for I1, in case select line is 1, I have a label y equals I1. I have assert statement, I have pass action and fail action. This is the design. I am creating a stimulus in switispeaks. This is my testbench file wherein I have I0, I1 select. I am initializing them to 0 and this is my output. I am creating an instance of my design. The name of the instance is that, wherein I am passing all these signals I0, I1, select and Y. Then I am giving some stimuli. After a delay of 10, I am reversing I0. After a delay of 15, I am reversing I1. And after a delay of 20, I am reversing select. They were all initialized to 0. Then I am dumping all these things into the waveform. Let's run this code and see the output. In this case, my design seems to be correct. When select line is 0, Y is going to I0. When select line is 1, Y is going to I1. So I am expecting this pass action to happen. Let's see if the pass action has happened or not. I'm expecting it to happen because everything which I have done here is correct. So let's see now. Yes, you can see all these displays. It means your design is functioning correctly. In case, say you want to open the waveforms, you can do that. Open eWave after the run. You save it and we'll try to run again and it will open the waveform for you. And here you can check when the select line is 0. When the select line is 0, that time the value of I0 should come to Y. That time the value of I0 should come to Y. And when the select line is 1, when the select line becomes 1, here it becomes 1, that time the value of I1 should come to Y. You can check in the waveform it's functioning correctly. Now let's do one thing. Let's close this waveform. Let me try to introduce a bug in the design and see if my assertion catches it or not. What I'm doing, say by mistake, for 1, select line 1 also I made y equal to 1 and for select line 0 also I made I equal to 1 by mistake say. Let's see if the assertions are able to catch this bug. If I run the assertion and it has opened the waveforms because I had told it to open the waveforms, but let's see if it's erroring out. Yes, you can see there are instances where you can see these errors. It means my assertions are catching the design bug. This is how your assertions can be used to check the design bugs. I hope you understood immediate assertions. I have tried to take a very easy example 2:1 marks so that it becomes easy for you to understand. You can try some complex designs and code the assertions and see if your design, try to introduce a bug in your design and see if your assertions are catching or not. To stay tuned to such content, please subscribe to Sweetie Speaks official YouTube channel. I, Sweetie Pinjani, will see you soon.